we got an integration question over here, and the question reads simply as, so this question is basically integral, a definite integral problem within the limit 0 to pi by 2 of this particular function. Now how we basically approach this particular solution? Now for the given integral, the integral is defined from the limit 0 to pi by 2 cube root of tan x whole divided by sin x plus of cos x whole square dx. So how to approach this particular question? So what I try to eliminate is basically, so this particular integral can also be expressed as cube root of tan of x whole divided by, if I try to take cos common out from this particular bracket, then I will be left out with tan x plus 1, and that will become cos square x into tan x plus of 1 whole square to dx. And if I take this cos square on the numerator term, then I will get this integral as 0 to pi by 2, and the integral will become cube root of tan of x into sec square x dx whole divided by tan x plus 1 whole square. So from here, if I solve this particular integral by substitution, that is, if I substitute tan x is equal to t, then what is the differential of tan x? It will become sec square x dx will become dt. So if we try to solve out this particular integral, this integral will take the form 0 to infinity, because at tan pi by 2 this basically approaches infinity. So this will become t raised to the power 1 by 3, and sec square x dx will simply become dt divided by t plus 1 whole square. So this particular integral becomes of this particular format. Now we already have familiar with particular format of integral is simply as a beta function. So this is basically a beta function. This is basically a beta function. Okay. So let us assume this beta function is basically of some number x and y. Okay. So how we will get this particular? We know the beta of alpha comma beta is simply integral 0 to infinity t raised to the power alpha minus 1 minus t whole raised to the power beta minus 1. And that particular format also assumes a very similar format, that is 0 to infinity t raised to the power beta minus 1 whole divided by 1 plus t raised to the power alpha plus beta into dt. This is a very similar format, and on this particular format, if we try to track back, we'll get beta minus 1 is equal to 1 by 3. From here, I'll get the value of beta as equal to 4 by 3. And similarly, we'll get alpha plus beta is equal to 2. And from here, if beta is 4 by 3, from there, I get alpha as 2 minus 4 by 3, which will simply become 2 by 3. All right. So this particular integral then finally assume the form of beta of 2 by 3 comma 4 by 3, and we already know how to solve beta function is basically by the use of gamma function. That is, this will simply become gamma of 2 by 3 multiplied with gamma of 4 by 3 whole divided by gamma of 2 by 3 plus 4 by 3, that will simply become 2, and gamma of 2 is equal to 1 factorial, that is equal to 1, and this will become gamma of 2 by 3 multiplied with gamma of 4 by 3. Now we already know a very important relation, that is gamma of 1 plus n is equal to, so let me write it as gamma of n plus 1 is simply equal to n into gamma of n. For n, okay, so this particular is a important property of gamma function, and from there this will become gamma of 2 by 3 multiplied with, and if this particular gamma of 4 by 3 can be written as gamma of 1 plus 1 by 3, and from here I'll get this is gamma of 2 by 3 into gamma of 1 by 3, 1 plus 1 by 3 will simply become 1 by 3 multiplied with gamma of 1 by 3. Now again we know another relation of gamma function is very important, is that gamma of n multiplied with gamma of 1 minus n is simply equal to pi divided by sine of n pi. So from there I will get that particular integral as, okay, that particular integral will simply become 1 by 3 times of gamma of 2 by 3 multiplied with gamma of 1 by 3. Now, this particular thing can be written as 1 by 3 times of, now gamma of 2 by 3 can be written as 1 minus 1 by 3 multiplied with gamma of 1 by 3. And this particular form simply assumes gamma of n into gamma of 1 minus m, which is basically 1 by 3 times of pi divided by sine of pi by 3. And we know sine of pi by 3 is simply equal to root 3 by 2. So that will become 2 pi by 3 root 3. Alright, so this is the final value of the integral, and that is the answer of this particular solution, integral. Alright, thank you.